हेलो, मैं हूँ आरजे और आज हम सॉल्व करेंगे कि 2025 केमिकल इंजीनियरिंग का क्वेश्चन नंबर 53। तो चलिए सॉल्व करते हैं।
So we need to calculate the steady state temperature at the wire solution interface. It means outer dia of the wire at which we need to calculate the temperature. So first we need to know about the radius of insulation. So we calculate radius of insulation to edit the radius of the outer dia of electrical wire is given 2 mm. So we convert it into m in meter is 0.001 meter because we need to calculate radius. So we take it as a radius and added thickness. So its thickness is about 0.002 m. So we calculate the radius for installation in 0.003 meter. Now I want in which radius of the outer dia on the wire is 0.001 meter. Now we know it's given about the voltage and current flow which flows on the wire. Basically, we know power supply applied to the wire is equals to V into I. So we need to calculate power, which unit is also in watt. So we have 2 into 5. It's exact 10 watt power which is supplied, which is converted into heat. So now need to calculate heat transfer through the from the wire to environment, which having insulation. So we write the formula which कर लेंगे. Yes, I correct here. The symbol is of current is I. Now which area is we need to calculate. So we need to that the heat transfer from the insulation heat transfer from the insulation to environment is in which area is used R2. So we write the formula of heat transfer. Uh, the heat transfer quotient and thermoconductivity of insulation material is given, and heat transfer coefficient of air is also given. So the temperature of the uh, ambient temperature of the air we already given 303 for basically converted the degree Celsius to Kelvin. So we put the values already seen in the diagram. So the radius R2 already we know 0.003 and length is also given is 5 meter mm. 5 meter in meter.
Mm.
I am solving in around 5 minutes. To get exam, you can solve easily around 2 minutes. Within 2 minutes, because you don't need of write the formula. You can just put the values that you know that already did and calculated that. So we calculated that values from the gate calculator. Now we know the power that supplied is converted into heat. It means that heat supplied it is also equals to power supplied. So we can also know we also know the heat transfer rate for unit is also in watt. That also we compare that. So we can put the value at the heat transfer rate is equal to 10 watt. So we calculating from the millimeter parts. So first further we calculate. Now we get the temperature. Now we get the temperature in the form Kelvin. That is 311.9521 Kelvin. Now in converted into degree Celsius, we need to minus 273.19 Kelvin. Now calculate it in degree Celsius. We get that answer that temperature is 38.8021 degree Celsius. That answer is the answer, and that is also lies in given answer key. Okay, thanks.